Morning once again, and if you haven't yet, please go to our polling page and fill in your responses to the poll questions for now week number 3. We do have 3 questions for today, so just be aware that you might only see the top one, but there are 2 additional questions that are below that, and yeah, perhaps we can kind of get started while you're filling in your last responses and see how things are going kind of overall. I think and hope that we have sort of technology that's going to play nicely so that we can end up with a screen recording this week, because unfortunately last week I don't know what happened, but the screen recording was not usable. So if you've gone to the course page and you've seen the video, it's unfortunately just sort of webcam picture of me, which is not really the nicest thing to look at in terms of learning materials because you can't see the screen. So I figured it was worthwhile to at least post that, because there were some instructions about things like how to set yourself up on the new CSC notebooks, but unfortunately the screen recording was lost. So we're trying now, I think, 2 other ways to record the screen this week, and hopefully this problem will not persist. I don't know, it's a very unexpected thing because I've used this same software to record the screen for many years in here, and it doesn't seem to have been a problem in the past. But yeah, how things are going for week 2 on what you learned. You can see kind of a quick list here of some of the different choices. So learning how to create lists, learning that the F strings are a fancy way for us to use things like print functions. So good to see that that you've appreciated the F string, because we'll see them throughout the rest of the course, and they are actually, quite handy. Otherwise, things basically about dealing with lists, some of the list methods like .index, that would allow you to find a value or the index value of some item in a list. And then it looks like there was also here listname.extend that someone must have looked up. Another one of the list methods that we didn't introduce, unless this is meant to be listname.append, but I guess if this is extend, I don't know if I've used this one. So, but yeah, there's basically what we were focusing on besides version control was about how to do things with lists for the most part, and how to interact with different data types. That was our focus for last week. And then, of course, as noted here in the last option, to use Git and to use GitHub. And that's something we'll get more practice with again this week. So that's good. In terms of how it's going with Git, well, it looks like I would say this is generally good. It's pretty typical that there's a bit of confusion about using Git and using GitHub, because it just kind of has its own vocabulary and way of doing things, and it can seem a little bit counterintuitive at first, but as you practice and use Git more and more, I hope that you'll begin to kind of appreciate why it's so useful and get more comfortable with how to do things and how to sort of remember the steps for when you want to, for instance, save a version of what you're working on to your GitHub repository. So this generally looks like a positive thing, but if it's still a bit confusing to you, don't panic. We'll have more time to work with Git, and of course, you're welcome to ask myself or Christoph or either of the course assistants if you have any questions. Or you can ask in Slack if you have questions about like why Git is doing something funny. There were some discussions going on in Slack this past maybe couple days about certain weirdness that had come up in someone's Git experience. And then finally about the pairs, for the pair programming, people seem to generally like this as well. That's good. You know, it is what it is. I think that's sort of also a representative comment for people's experience working with pairs, because it does take more to coordinate working with someone else. And sometimes that is a more like a laborious task than doing the work itself. So I think we understand that it's not always better for everybody to work in pairs, but we like to have you working in pairs for the first few exercises, just because they do tend to make a lot of like little syntax mistakes, and having a second set of eyes looking at what you're doing while you do it is a useful way to avoid you getting frustrated and like bogged down with little like missing parentheses or quotation marks or whatever, and not being able to focus actually on like what you're trying to do with the Python code itself. So this is good in general. I guess I wanted to note a couple things about the pairs. There are some issues that people have noted in Slack. In some cases, people's partners have not been responsive, or their pair has not responded to their messages. In other cases, their pair has dropped the course. And if you're in one of those situations, maybe when we take the break today, it'd be good to come and just have a quick chat with me so we can make sure that those of you who need to be repaired with somebody else can do that and do that without too much delay. I was also going to note that I think because of the issues with some of the pairs, that we'll extend the deadline for the exercise for this week to the end of the day on Friday, so that if you've been having a hard time with like coordinating with your pair, that you have maybe an extra couple days to sort that out. And if you need to be paired up with someone else, for example, that we can do that today, and then hopefully you'll be able to at least talk with the partner and be able to coordinate things for this exercise that's due now at the end of the day on Friday. So yeah, sorry, I've been a little bit slow to get all of the kind of repairing issues going and sort of totally sorted out, but I think we're aware of most of them. But if you're still having problems with your partner not responding, or you're unhappy with something else about the pairs, just again, come talk to me at the break when we take that. Are there any other questions or things here that didn't end up in the feedback here this morning in the poll? Okay, yeah, so good question. The question basically, that I'll just repeat so it's recorded here, was whether it's okay to sort of still both do your like own thing with the exercise, both turn in your own answers to the exercise and all of that, submit everything to GitHub for each person in the pairs. And of course, that's fine for you to do. The only thing to be aware of is that we only grade the exercise that's for the driver for that week. So you're both welcome to submit the exercise. We just won't grade the other person's exercise. So it's probably actually not a bad thing to go through the process of working on your own. But yeah, you just won't get any feedback for that. It'll only be given for the driver of the pair for that week. So yeah, any other questions? Okay, so if not, why don't we go here and take a look at what we're dealing with this week. I gotta refresh the course page. And here we are in lesson number 3. And yeah, this week, I think we have a little bit easier task in a sense this week, because we're just basically going to focus on Python stuff. So we won't mix in learning more version control stuff. We won't mix in much new things in terms of working in the CSC notebooks or anything like that. But we're going to focus basically on 2 main concepts for today's lesson. And one of them is about loops, and specifically we'll be working with a for loop, which is a way in which we can repeat a piece of code or section of code a finite number of times. And then we'll also be working with conditional statements. And so these will be ways of making decisions in your code using statements like if and else that would allow you to sort of say, if a certain condition is met, do this, and if not, do something else. So it's a way of kind of controlling which parts of your code will be executed. And of course, like always, we also have a good coding practice about writing readable code, which I hope we'll have time to go through at the end of the lesson today. But yeah, first things first, I guess I did not myself get my CSC notebooks session open. So if you haven't done that yet, it'd be good to log into the CSC notebooks platform now, and we'll get up and running like that. So I'm going to go ahead and open my Geo-Python 2022 session. And as you all know, like last week, it may take a moment for this to launch, especially with all of us opening them at the same time, but let's hope this launches fairly quickly. And in the future, you're more than welcome to open up your CSC notebook session kind of when you arrive here so that, that you're ready to go. But yeah, I'll wait just a minute because I'm guessing some people are still going to be getting set up here. And we do have to do one thing that we didn't do last week, which is to get the latest version of the notebooks for this week's lesson. So we didn't go through how to do that last time because last time we were cloning the notebook repository for the first time. And today we're going to basically just show you how to get the latest version of the notebooks, which would be the ones for lesson number 3. So once you are in the CSC notebooks environment, in your JupyterLab environment here, you can go to the My Work folder. And if you double click on that and then go to your notebooks folder, you should see that right now you have L1 and L2 in the notebooks folder. If you cloned it last week, that should be the case. If you didn't clone the notebooks folder last week, maybe it's good to work in Binder for right now until we have a chance to explain how to clone that. Or you can take a look at the course page. There's instructions on lesson 2 about how to, or actually might even be in lesson 1 about how to clone the notebooks. But I would think that most of you that were here last week should see already that you have this notebooks folder here with these 2 directories, L1 and L2, that are there. If you then go to the Git plugin thing over on the left side, you should also hopefully see that this recognizes you're in a Git repository. And because it recognizes you're in a Git repository, you'll see things like, after a moment, remote changes that pop up. This is basically telling you that there's new files that are in GitHub that you don't yet have locally on your cloud computer in the CSC notebooks. And so in order to get those, you'll need to go up to the top to this little cloud icon with the down arrow on it to pull the latest changes. And I hope if you just click that, it should be successful for everyone, because I don't think there should be any kind of potential conflicts. Unless you had created a directory called L3 yourself, this should be perfectly fine to just click the button here and clone it. And at that stage, then what you should see if you go back to the file browser is that you now have an L3 directory as well. So maybe by show of hands, is there anyone who was not able to get this L3 directory by pulling the latest changes from GitHub? Yeah, so each week, at least for the way that we have things configured right now, each week we'll do this as our kind of first step. We'll log into CSC notebooks and we'll grab the latest notebooks for whatever lesson we're working on. And so again, this process itself will get a little bit easier, I think, through time, because we'll just get more practice doing it. But yeah, once you're here and you can see in the file browser that you have this L3 directory, you can go and you can open the for loops notebook just by double clicking on that. And maybe I will make my screen a little bit bigger and hide the file browser so that we can see what's going on here. So basically, we're going to start by kind of introducing the idea of what a loop is in general. And again, not assuming that you've done any kind of programming using loops before. And we're going to start actually with a bad example, because this is kind of a useful way to illustrate why it's good to use things like a loop in general. So we have here a list of European cities. It's already filled in the notebook, so you can just click on the cell and press Shift-Enter or the play button up at the top to run it. And that's going to store a list of 4 cities, so Helsinki, Paris, Barcelona, and Uppsala, in our variable called European cities. And if we wanted to go through and see each of the cities that are in there, we could basically type in European cities, and then in square brackets, 0, for example, the index value of the first item in our European cities list. And whether you print this out or whether you just type in the name of this value and hit Shift-Enter, you'll get the same output here, which is Helsinki, as we can see, as the first item in our list. No surprise there. And if we wanted to do this for the others, maybe the easiest way is to kind of copy the text and paste it in here and do it for index number 1, and we see Paris. Index number 2, we see Barcelona, and finally Uppsala as index number 3. Just copying and pasting and changing the index values there. So we could go through manually by hand and just iterate through the values in the list like that to be able to see what the values are themselves. But this is not a very good way to do things. You can probably already guess that this is not going to scale nicely for long lists. So if you have 10,000 items in your list, I don't think you're going to want to copy and paste and change the index value by hand, because not only is that a tedious process, but you're probably going to make mistakes. And the more that you sort of manually have to change values in the code to do things, the more likely you are to, unfortunately, make a mistake in what you're doing. The other thing is that the same approach won't work very well if we have fewer than 4 cities, for example. So imagine we have now Riga, Rome, and Athens as our 4 cities. So I'll run this cell again just to overwrite the values that are in the European cities list there. And again, I can go and just paste what I had before, European cities 0, and I get Riga. And if I go to index number 1, I get Rome. Index number 2, I get Athens. But then if we keep with this exact same workflow and I try to access the value that's at index number 3, of course that doesn't work because there's only 3 items in the list and I'm trying to access the 4th one, which is simply not there, leading to this index error. So we saw these index errors already last week when we tried to do things like go beyond the length of a list using the index values, and that's exactly what happens here. So this isn't the way to do it. And we kind of just start with this example just because this is probably how you would have done things last week if you were asked to go through and print out the items in the list one by one. Well, the way to do that last week was to edit the index values, and today we're going to learn something that's a bit better approach for how to do that same operation. So let's do this now a little bit smarter way, and that is to first here under the introducing the for loop heading, run the cell here for European cities to put in 4 more. So now Amsterdam, Brussels, Lisbon, and Reykjavik. Those are our 4 cities, and if we want to print them out, what I would say is perhaps a sort of slightly smarter way of doing it, we can do that using a for loop. So we could say, for example, for city in European cities, and then colon. So we're going to set this up with the word for. City in this case is just a variable. It's the kind of variable that we're going to use within our for loop. But it should be, it could be something other than city, but we'll use the word city because that makes sense in this context. Then we have the word in, and then we have our list. And this could be a list of, it could be a list, could be another kind of collection, but it should be something like that. And then, of course, the important thing is that this line ends with a colon. When you press enter in your notebook, not shift enter, but just enter by itself, what you should see is that your cursor automatically gets indented underneath this for statement. And we'll talk about what that means in just a second. But if we wanted to sort of see how this works just as a working example, we would then put print city underneath here. So already maybe you have some idea what this is going to do. And so let's run it. And what you can see is that this little piece of code goes to each one of the items in our list and prints it to the screen. So the way that it's working is that we have some variable name here called city, and each time it goes and finds an item in the list, that value gets assigned to city, and then we have a print statement that prints that out to the screen until we hit the end of the list. Once the end of the list is encountered, then all the cities will be done being printed, and that's it. So we'll talk about the sort of structure of a for loop a little bit more in just a second, but what's nice about this is that this works very flexibly as the length of your list changes. So if we had, instead of some European cities, some cities in the US, we can run the cell here to fill in the variable name US cities and use the same basic structure that if we said for city in US cities, colon, we could then print the city. And so now we have 1, 2, 3, 4, 5, 6, 7, 8 cities in our list. We use code that looks almost identical to what we used before. Other than European cities, we've replaced that with US cities here. But when you run this code, you now see the 8 cities that are in that list printed out to the screen. I guess you could imagine that this will nicely scale up to large numbers of items in lists. If you have 100,000 cities to print out, rather than having 100,000 lines where you sort of individually print them one by one, you can do that in 2 lines of code. So this is a far more efficient way to go through items in some kind of collection and do something with them. So those are a couple examples. Let's take a look now maybe at what the sort of structure is of a for loop, just to make sure that we understand how it's set up. So the basic structure starts with the keyword for. That's the way in which you sort of identify that you're going to be wanting to loop over some list of values. Then you have some variable name here. In our case, it's been the word city, but this can be any variable name as long as it's not something like a reserved keyword like true or if or something like that. But this could be any kind of name you want to use for the variable here, and then the word in, and then you have some kind of collection. So the only collection we've really dealt with so far is a list. So for us, we're going to basically be going through lists and doing things. And then you have the colon that indicates that's the end of your for statement, and then underneath that, we have this indented code here. So this, in this case, obviously is not Python code here, but this indicates that anything underneath the for statement that's indented is what you're going to be doing each time you go through your list of things like the list of cities. We're just printing each one of them out one by one. So yeah, key things here. Variable can be anything that you want to call it. The word or the statement must start with the word for and end with a colon. And then everything that's meant to be executed inside of this for loop should be indented beneath the for statement. And Python is strict about this. So you are required to indent things underneath things like a for statement. And as we'll see with conditional statements, it works the same way. If we have if, the code needs to be indented underneath there. The standard in Python is 4 spaces for indentation, although you are able to use more or less than that as long as you're consistent. If you want to indent 2 spaces, you can. Style-wise, it's suggested to use 4 spaces, but compared to some other programming languages where this indentation thing is not a requirement, it is required in Python. So if you've used, I don't know how things work in Java, for example, but I know at least in other programming languages like Fortran, C, C++, they don't care about indentation at all. That's mostly kind of a style thing to make it easier to read your code, because when you indent things inside of a loop, for example, you know what part of the code is actually being executed in the loop. In a lot of other languages, it's just a visual key. In Python, it's important and actually required to indent things. And there's no word that you need to use to indicate the end of a loop as a result. So this is a design choice in Python, that because everything here that's going to be executed is indented, as soon as the indentation ends, that indicates that the code that's part of the loop is also no longer going to be executed in the loop. So for some other programming languages, you might have to have like a do and an end do statement to indicate the start and end of some kind of loop. But in Python, you just stop indenting, and that indicates that your loop is ending at that point. So yeah, for us, I mean, for loops, these are very useful for doing something a finite number of times, like going and printing out each item in a list, for example. And in terms of sort of way of thinking about this in an everyday context, there's a couple examples here. One is a sort of daily planner for a cat, which involves a lot of sleeping and occasionally acting crazy. But this you could imagine like would be every day in the cat's life. It sort of wakes up and does this same set of things. And you could think in our lives, for example, that we have a certain set of things that we might regularly do every morning. So for day in my life, so if my life was sort of a list of all of the days that I'm alive. For any given day, I might wake up, take a shower, eat breakfast, brush my teeth, and blah, 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 whatever they're going to do for the rest of the day after that. So there's a certain regularity of doing certain operations every day that we could almost consider in the context of something like a loop. So anything that gets repeated, the same set of operations happening, for instance, on different days, we could imagine that would be an equivalent to a for loop or to a loop in general. And in this example, things like wake up would be some function, and so that whatever that involves, if it's the alarm clock waking you up or whatever it is, that would be that happens each morning, hopefully. But yeah, that's the kind of way to think about it. So we had our vending machine last week to talk about like lists and their index values. Here, when you think about a for loop, you can think about repeating actions every day in your life as a kind of analogy for how they work. So let's explore a little bit more now how these for loops are working, and we can do this with another list. In this case, we have some weather conditions. So again, you should just be able to run this code cell for weather conditions. So we have rain, sleet, snow, freezing fog, sunny, cloudy, and ice pellets. I think these are weather conditions that I took from common conditions in the part of Canada I was living in before moving to Finland, although these could probably equally apply here. And yeah, if we take a look here and have some for loop where we print out each one of these conditions. So we could say again here for weather, in weather conditions, for example, we could then print out what the weather value is. And as you know, at this point, the expectation would be that we're going to print out each one of the items in this list. So should be no surprise when we run this that we get rain, sleet, snow, freezing fog, sunny, cloudy, and ice pellets. The thing is, this variable weather is just a normal, regular Python variable. So if we printed, for example, get a little F string practice here, we could say after the loop, the value of weather is, and then we can put the curly braces here in the variable name, weather. So this allows us to check and see what the value of this variable called weather is after this for loop has run. And we're using an F string here. So again, starts with the letter F, and then you have the quotation marks wrapping around here. And any place where you want to insert a variable value, you put it in the curly braces. So what you see here is when you run this, after the loop, weather is ice pellets. So that is the last value that was printed out when using this for loop, trying to highlight just this. And so that value that was printed out for ice pellets, for example, last item in the list, it's also the last value that was assigned to the variable weather. And after the loop has run, that value is still assigned to the variable called weather. So it's just a normal variable. The reason that I point this out is that you do sometimes have to be a little bit careful, because in your code, for example, if you've got for loops where you're using a variable name inside there and then you later use that variable name elsewhere in the code, you can sometimes get unexpected output. So just be aware, it is a normal variable and it will still be available to use and to access after a loop has run. All right, so let's take a look now at another way in which we can use for loops, and that is using a function called range. Now, so far what we've been doing is going through some list of items and printing out each of the items one by one, directly accessing the items themselves. But we can also access values using the index of the value in a list. So let's take a look first off just to see how this range function is working. So we could say, for example, here for value in range, and then in parentheses, the number 5. So we're going to have another for loop here, and in this case, we're just going to print out value. So for value in, and instead of having a sort of already created and assigned list, we're going to put in this range function call with the number 5 in it, and then we'll print out what we get for value. When you run this, what you'll see is you get 0, 1, 2, 3, and 4. So what this range function is doing is basically providing a list of numbers, and in this case, if you give it just a single value here, what it does is it gives you 5 numbers starting at 0 and going in whole number increments up to, in this case, 4. So it doesn't go up to the number 5, but it gives you 5 numbers back when you use the range function with the number 5. So this is sometimes a little bit confusing because you might expect to see the number 5 in the list of numbers here, but of course the way that it's working is it just gives you 5 values when you use the range function. So, okay, that's something. But the range function can do more than this, and we haven't yet seen how to use any kind of documentation in Python, so this is a good place to kind of see what can we do with this range function. And if you go here and you type in the word help and then in parentheses put in range, that will give you the documentation that's built in Python that tells you how this range function is working. So I run this code cell and I get a whole bunch of stuff here. Most of what we need to pay attention to is up at the top. And what it tells us basically is that this returns an object that produces a sequence of integers from start, inclusive, to stop, exclusive. So in this case, if you list both a starting number and a stopping number, it will start at whatever number you have listed here, and it will stop one value short of that stop value. So if we, for instance, here modified what we had done up above to say for value in range 0, 5, 0 would be our start value, 5 would be our stop value. 5 will not be included in the list of values that get printed out here, and in fact, this doesn't do anything different than what we had already done before, because if you don't list the start value, it's assumed to be 0. So instead, we could start at 2. And if we run our range function with 2, 5, you'll see that you get 2, 3, 4. So it's going to start with this value that's listed here. But again, it will go up to but exclude the number that's listed for the stop value. So that is a little bit of a tricky thing to work with sometimes. You have to just pay attention when you're using the range function what numbers you actually want to have. But you can see the documentation that's given here. And what you can do with that then is I will go here and maybe hide a few of our questions from before and make this one visible. And yeah, our question here is about using this range function. So if we had something like code that looked like for I in range and ... is what you're going to have to think about, print I. And the goal here is to figure out what would you have to put in based on your understanding of the range function and using the documentation that's listed there to get your for loop to print out 2, 5, 8. So you can go here to the polling page, and maybe I'll go back actually here to see the question, and you can select based on your understanding of the range function at this point which values you think you would put in to range in order to get 2, 5, 8 as the output. So think about that for a moment, and then we'll continue from there. So which values would result in the output from the range function being 2, 5, 8? So there's 2 of the options here. It's basically 2, 8, 3 and 2, 9, 3 that were suggested. The way that the range function is operating, the first value would be our start value. We know if we want to start with 2 as the first value there, of course, that's going to be the first number we list here. The second is the stop value. And again, the sort of funny thing with the range function is that the stop value is excluded from the values that would be printed to the screen. So if you were to print with 2, 8, 3, for example, you would only get the output 2, 5, and you would not get 8 printed to the screen because that stop value is excluded in the range function when you use it. 3, of course, as both of the suggestions here indicate, is the increment between the values. So for us, if we were to go and try to do this, we say for I in range 2, 9, 3 would give us the correct output because we'll start with 2, we'll go up to 9 but not including 9, and then we'll use an increment of 3. And if we then print out what our value of I is here and run this, you indeed get the 2, 5, 8 as one possible solution. As it turns out, you could also do 2, 10, 3 and get the same output. And if you were to do 2, 11, 3, you would also get the same output. If you put it up to 2, 12, 3, then you're going to get 11 included in your list. So there's more than one possibility here, but the way in which you would probably do this if you were tasked with having to print out these 3 values would be to put in 2, 9, 3. Again, recognizing that the 9 goes up to but does not include the number 9 in the range of values that would be printed to the screen. All right, so maybe now you have some sense of how this range function is working, but what you probably don't have is a good sense of why we are bothering with this range function at all. And so we can take a look now at a couple examples that might help to kind of illustrate that a bit better. So first off, we have this list of numbers. And again, like we have dealt with earlier, we can basically just take that list of numbers and run that code cell to be able to store that in memory. And what we're going to do in this example is we're going to take our list of numbers and we're going to add a value from the range function to each one of the numbers in the list and then print that out to the screen. And we'll do this again with a for loop. And we can say for I in range. And in this case, we're going to use a function we haven't used yet called len. And then we'll put in numbers here, and I'll explain what this does in just a second. So you have your range function like you normally would, but then in the parentheses, instead of a number here, you have this len numbers function. Len will give you the length of a collection, length of a list, for example. So basically what this is going to do here, len numbers, since there's 4 items in our list, would give us the number 4 in our range function. So we would have range 4 essentially as what the output, or how the range function would see this, because len numbers would return the number 4 when you use it. What we want to do then, using this range len combination, which is actually kind of fairly common thing to do in when dealing with lists of values and wanting to use their index values, is to print out some different things to the screen to see how this is working. So first off, we can have a print statement here where we'll do another f string, and we could, for example, say the value of I, and then we'll put the curly braces and the letter I there. So if we just run this like this by itself, our range function is going to give us 4 numbers, and the variable I is going to store each one of those 4 numbers as we go through our list. The reason for using this letter I is it's a very common thing to use when you have a list of like index values that you're going through, for example. It doesn't take very much space, and so this sort of typical use of the letter I, for example, would be to indicate you're in a loop and you're going through and iterating on the values in the loop. So if we run this, what we see is value of I 0, 1, 2, 3. That's not a big surprise because len numbers give us the value 4. Range 4 would give us 0, 1, 2, 3. 4 numbers starting at 0 and going up to, but not including 4. Okay, let's actually do something with these numbers now. So we'll have another print statement, another f string. And we can say the value of, let's call it numbers at index I. And then we could put some curly braces here and put in numbers I. So this is just going to then go to the location of whatever the index value is in this case. So our value of I, as we just saw, is going to 0, 1, 2, and 3. So we're going to go to that location in our numbers list and print that out. Again, we can run this, and what you can see is now that value of I is 0. Value of numbers of I is 5. So you remember, just like pushing the buttons on the vending machine, we're going to location 0, the first item in our list, and where there we find the value 5. Let's add one thing here. And that is, we can say the value of numbers of I before addition. Because we're going to add now our value of I to the value that's in numbers of I. So we can do that here. If we go numbers I equals numbers of I, or numbers at location I, plus the value of I itself. So this loop is now going to go through and go to each location and add something. In this case, it'd be the value of the index to the existing number that's there. Let's then copy the line above and paste it in below, because it's going to be faster than typing this in again. But let's say the value of numbers of I after addition. And I guess actually in formatting this, I could make it probably look a little bit more reasonable if I put this before and after thing into a more sensible place. But don't worry about that. It's just a minor kind of formatting thing. And then just to make it easier to read, let's add one more print statement in here with just an empty string. That'll just give us a blank line between each one of these things that we're running. So our for loop is getting a little bit longer. As you can see, all of these lines are indented in here, so all of the lines will be executed each time we go through the for loop. And what we should expect to see is that we'll get one line printing out the value of I, which we're going to use as our index variable. Then we'll get the value of numbers at that index location. Then we're going to modify the value of numbers at that location by adding the value of the index to it. Then we'll print out what numbers is after we've done the addition, and then we'll print a blank line there. So a little bit more complex example, but if we run this, we should get some nice looking output here. So the first time through, our value of I is 0. So before addition, the value of numbers is 5, and when we add 0 to 5, we still have 5. So that's not a big surprise. The next time through, our value of I is set equal to 1. So the next time we after we've executed all of these lines, we come here. The next number in our length, our range function is going to be 1. The value of numbers at index 1 is 6, but then after we add 6 plus 1, we get the value of 7 as the new value at that same location in the numbers list. And of course, the next time through, when the value of I is equal to 2, we're going to go to the next value in the list, which is 7, and then add 2 to 7, and you can see that we then have a value of 9. And finally, we go to index number 3, where we find the value of 8. There it is. And then after running this addition line, we have 8 plus 3, of course, is 11. So that's how that's working with the for loop. And in that example, I think that kind of covers one way in which we could see things if we want to. For example, at the end, just see what numbers looks like after modifying the list values. You print out numbers and you can see now it was 5, 6, 7, 8. And after doing this addition where we've modified the values in the numbers list, we have 5, 7, 9, 11. So coincidentally, adding our index value here is giving us all odd numbers. That's purely coincidental, wasn't planned. So yeah, I think you can see a few things about how the length function can be used here, how the range function can be used, but we still really haven't talked about why you would want to use index values to loop over a list. Like, why not just use the values directly? If we have a list of cities and we want to print out the cities, why don't we just go for city in European cities or whatever and print those values out? So let's take a look at an example here, and we'll be then having a quick check your understanding opportunity and maybe taking a break. So here we've got two lists, one of cities and one of countries. And so these are capital cities for the Nordic countries in this example. So let's run the two cells there. And what you can see is that we have, for example, at the first location at index 0 in our cities list, Helsinki, and the country is a corresponding country, Finland. And if we were wanting to, for example, print out each one of the cities and the countries together, we can do that. But this is maybe one of the examples or use case where using the index values might be helpful. So in our case here, we could say for I in range, and then leng, our len function, which again short for length, and then one of our two lists that we have here. We could use cities or we could use countries. It doesn't matter. They both have the same number of items in them. We could then have a print statement here, and let's do it with an F string, where we could say cities at location I is the capital. Oops, I gotta put this inside the quotation marks. Is the capital of, and then countries of I. So what this should do is go to each one of the index locations in both of these lists and first find a city at this index I. And our range function, again, is going to give us a list of numbers 0, 1, 2, 3, 4, which would correspond to the index values of the items in our cities and countries lists. And it's going to go to cities at that location and say, is the capital of countries at that same location. So if we run this, what you should hopefully see is that Helsinki is the capital of Finland, Stockholm is the capital of Sweden, Oslo is the capital of Norway, etc., etc. So this is an example where using the index value is useful. It's not the only way that you can do this. There are other functions like enumerate that you can use to do the same kind of operation, but for us, this is kind of a useful way to do it because we have two lists, they have the same number of items, and each item between the two lists connects to one another. So by using the index values, we can go to corresponding locations in both lists and access information from both at the same time to do things like print out our list of capital cities and the country that they are the capital of. So you'll see in the exercise for this week that you get some practice doing things like this, using the index values to access values inside of a list. It's pretty common to have lists where you have a variable name and then information that corresponds between perhaps multiple lists. Could be sort of locations where you have latitude, longitude, and elevation, and they're all three separate lists, but they all correspond at the same index to the same location, and you may want to access those at the same time. Okay, so why don't we do this? We have a check your understanding opportunity here, and we have two lists, odd numbers and even numbers, and then we have a for loop here that goes through and it does something where we add the items from odd numbers and even numbers together. I will make the poll question visible, and why don't we do a combination of things here? So you can fill in your responses, and we'll also take our break at the same time. And why don't we take 15 minutes, just because that way you have time to fill in your response and have a little bit of opportunity for a break. And so we'll continue at 10:35, but in the meantime, fill in your response to the poll question. I'll make it visible here in just a second. And yeah, we'll continue in 15 minutes.